Good morning, ma'am. My name is Yelmonika. I'm currently pursuing my BTech third year in ECE branch at a Sarati College. Today, I'm going to explain about the EM algorithm under the subject An Introduction to Machine Learning. My topic is the expectation maximization, that is EM algorithm, and solve problems of latent variables and missing data. First, let me give you a brief introduction, brief summary of today's topic. Um, First, I will discuss about introduction to EM algorithm, and then I will discuss about need of EM algorithm. Then the key concept, that is latent variables, and I will discuss about the two pillars of EM algorithm. And then I took an example, that is Gaussian random variable. These are the contents that we are discussing in this presentation. First, let us discuss about introduction. Coming to what is an EM algorithm is, it is an alternative method to find maximum likelihood estimates for model parameters. The problem is used when the model depends on unobserved variables. And how it will be solved is, it is like trying to group people into different rooms when you don't know the room assignments or the average profile of each group at. This is the introduction about EM algorithm. Then uh, we'll move to why we need EM algorithm. Why we need EM algorithm in machine learning because in simple models we use MLE to find parameters. But in complex models with missing data or hidden clusters, the log likelihood function becomes mathematically messy and hard to solve directly. EM algorithm breaks the problem into two easier steps. And the steps are, now coming to key concepts, that is latent variables. In latent variables, we observed two parameters, that is observed data, it is denoted by X, what we actually see, and the latent variables, it is denoted by Z. Hidden factors that influence the data represents Z. And the complete data. This is a combination of observed data and the latent variables, that is X comma Z. Now, the goal is estimate parameters 0 that maximize the probability of seeing X, means observed data. Now, coming to the two pillars of EM algorithms are E step and M step. E step means expectation. Guess the value of the hidden variables based on the current parameters. This is the first pillar of EM algorithm, where we can find hidden variables using current parameters. And the second step is called as M step. This is also known as update hypothesis. We can update the parameters to better fit the guessed data by using this step. These are the two pillars of EM algorithm. Now, let us understand by using step-by-step procedure. In EM algorithm, first we initialize, means start with random parameters, and then we go for E step, means calculate the probability of latent variables given the data and current 0. First, in E step, we calculate the probability of latent variables. And then the next step is M step, where we find 0 that maximize the expected log likelihood. And then we check convergence, means repeat until the parameters stop changing significantly. This is the step-by-step procedure in EM algorithm. And the mathematical foundation of each step is, this is the first pillar of EM algorithm, where we define Q function. Q function can be defined as Q of 0, 0 XOR of T, where E equals to Z R X comma 0 XOR T, ln P of X, log of P of X comma Z or 0. We calculated the expected value of log likelihood of the complete data by using Q function. And the mathematical foundation for M step is, first M step means update the parameters for the next iteration. The mathematical expression is 0 XOR t plus 1, argmax of 0 q of 0 comma 0 0 exactly. This is the mathematical foundation for n step. This ensure that the likelihood p of x or 0 never decrease. Now, let us understand by taking an example that based on Gaussian mixture models, this can be represented as GMM. Now, let us take a one scenario. Uh, you have a data sheet that look two overlapping humps, means distributions. Now, calculate the latent variables which hump cluster. Hump means cluster. Does a specific data point belongs to? And now parameters. Calculate parameters mean, variance, sigma square, and weight pi of each Gaussian. Now Gaussian models. First step is E step. For every data point xi, calculate the responsibility. And now the question is, given the current means and variance, how likely is it point xi belongs to cluster A versus cluster B? This is a question. And the second step is M step, means update, means calculate the new average of points weighted by the responsibility to that cluster. And update variance by calculating the spread based on the new mean. And we can update weights based on see what fraction of total population belongs to each cluster. Now let us see about EM algorithm versus K-means clustering. In EM algorithm, features are assignment. In K-means algorithm, hard of 0 or 1. But in EM algorithm, soft probabilistic. And cluster shape in K-means is spherical, and in EM algorithm is elliptical or flexible. And the information in K-means is distance based, and the information in EM algorithms is density based. And these are the limitations of EM algorithm, where local optima, it can get stuck in local maxima instead of global best. And the speed can be computationally expensively for very large data sets. And the initialization, the final result often depends on the starting guesses. Now, I want to conclude this presentation by giving a brief summary of this presentation. EM algorithm is a fundamental algorithm for unsupervised learning. It handles the chicken and egg problem. We need parameters to find latent variables and latent variables to find parameters. The applications of this EM algorithm are image segmentation, NLP, hidden Markov models, and bioinformatics. Thank you.